Welcome to your first CV2 video. This video is pretty much for everyone who has never done anything with Circuits V2, who don't know any pins, who don't know any functions, basically nothing. Let's say you're starting off fresh, that is why I made the video. In the first video we're gonna go over every pin in the game and what they mean, what you can use them for, and pretty much basic things so you'll know how to begin. And with this video out of the way, when you're done with it, you'll be able to follow along pretty much any video I'll be doing in the future. So, we're gonna go over the variables first, because this is the easiest way for me to demonstrate and show you pins, different pins you'll be able to use throughout your experience with Circuits V2. We're gonna start off with the core material. With that I mean things that we'll see in every programming language, every game, pretty much anything. That is instance int, short for integer, instance float, short for nothing, it is float, instance string, which is also short for nothing, and the instance boolean. Now what are these exactly? Basically instance int stores whole values, so 1, 2, 3, 4, and 5, and the pin of it is green. It's always going to be green. Whatever circuit you see it on, it's always going to be green. Next up, instance float also stores numbers, but in this case they can be more precise, which means decimal spaced. So while the integer will be 1, 2, 3, and 4, the float could be 1.1, 1.2, 1.3, 1.4. Of course it could be even more specific, for example 1.0004, but these are just examples. The float pin will always be blue. Next up we have instance string. Instance string is basically raw text. Anything you see written on your screen is pretty much string. Every name here of these variables is defined with a string. And the pin of the string will always be purple. And last one is instance boolean. So the instance boolean can only have two forms. It could be true or false, nothing else. The best way to give you an example of a boolean is if we ask ourselves if this specific platform here is green. We can only, pretty much answer, yeah, it is green, or no, it's not green, which means true or false. In our case, it is green, which means it's true. So basically, variables in general store values, but you can never store multiple in a normal variable like this, but you can in lists, which I'll show you later. So these are the core basic variables, but we're gonna spawn the others in as well. So instance competent, instance AI, instance creation object, instance player, instance vector 3. So, instance competent, instance AI, instance creation object, player, and vector 3 all have the same pin. Now, the colored ones, as you've heard earlier, are core basic ones, which means they're always present everywhere, in every game, in every programming language, anything. But yellow means things that are made for this specific game, or yeah, just game specific in general. It could also be in other games, but in Rec Room it is defined as it is. So I'm gonna go through all of these. Instance competent tells you what it is. It's a combatant, someone who is in progress of a fight or anything like it. Instance AI stores AI. So, for example, one of those goblins from Golden Trophy, you can store that in here. Instance creation object is an object that got created, something that exists, that we made. We could store objects in here. And last, on this row, instance player. Self-explanatory, we store a player in here. In my case, no one's here, so I could only store myself in there. And then the last one, instance vector 3. This is the most special out of all of them. All of these store a specific object, so to say. This one stores a value. Now vector 3 is coordinates or orientation of a 3D space. Now it's game specific because Rec Room is a 3D game. by moving my random character, I change my vector 3 position. Basically x, y, and z coordinates. Now we can store that in here. So vector 3 is a set of 3 values, so 3 numbers combined into one. Let's say 50, 30, 40. Those are coordinates in a three-dimensional space. So if we go over to our list of circuits, we can find things that are for our vector chip. So here are vector create, vector split. These are the 2 basic ones. So it's simple. Vector split means we give this circuit the vector, which can be stored in here. We put it in here, and it splits it into 3 values: the x, y, and z coordinates. This is how we could take out a specific coordinate and use it to our advantage. Now, blue, right? If you remember from earlier, blue means float, which means a more specific number, which could be decimal spaced. So again, to repeat, this is the float. It could be 1.1, 1.2, 1.3, so on. While the integer also stores numbers, but they can only be whole, so 1, 2, 3, and 4. Now the vector create, we give it the coordinates, and it creates a vector out of it. And we can store it back here if we wanted to, but that is your decision what you want to do with them. So we went over basic pins, which are green, blue, purple, red, and yellow. But there is 2 more. A good way to show you that is through this one, this specific circuit. It has the 2 other pins that we should mention. So as you can see, this one is a bit weird. Right? It's not the same as any of these, and it's a bit bigger. Basically, this means a signal pin, I like to call it. Power pin, signal pin. Doesn't matter how you call it. The only thing that matters is that you understand what it is. So this only serves for activation. It doesn't output values that you can use, but it just outputs signals that trigger other circuits. Then we have a white pin. A white pin is basically universal. Whatever you hook up to it, it'll take that form. Which means that if we hook up a green pin, which is an integer, every universal pin on the circuit turns into that specific type, which means that by connecting my integer to a neutral universal pin, every universal pin turns into an integer pin, which is green. As you can see, it lights up. So if it's just a normal color like this, it means it's not active, it's not being used. But if we hook it up to something, it becomes neon, which tells us that it's currently hooked up to something and is being used. It's not just being there, but it's actually, being used. So, these are pretty much most of the pins you have to know. Now there's one more pin I would like to show you, which is called a list. So let's just take this as an example because it's right here. So a list is basically a variable like this, but instead of storing one value, you can store multiple. So a good comparison would be an instance string and an instance list string. The instance string can store one thing. We could store the word hello in here. But here, we can store multiple things, such as the word hello, goodbye, see you later, whatever. Now strings, just so you don't get confused, strings aren't only one word. They can be a whole sentence. Because they're always just separated by its identifier, a string identifier, so to call it. But that's more coding things that you don't need to really remember. So yeah, these are the pins that you need to know pretty much to work with Circuits v2. Now for all of you that already know something about Circuits v2, you spotted one error that I made here, which is this. Now the set value chip and everything that comes with it I will be telling you about in the next video, but for everyone that already knows about it, this is the variable, right? And you hook up the variable to the variable pin, not the value. The value, you just have to set something that you want in here. But more about that in the next video. Thank you for watching. I hope this made it more clear to you. If you have any questions, you could comment down below, or join my BOC Discord, which is my class Discord. Ask any questions about Circuits V2 you have, and I'll try to answer them as best as I can.